Go ahead and move on. All right, so our margin of error. So this is kind of our first step, right? It's finding our margin of error. So it's the amount that we're adding and subtracting from our p hat or our x bar. It's our critical value times our standard deviation. In this case, for our proportions, our standard deviation is square root of p hat q hat over n. Where does that come from? It comes from the fact that, remember our standard deviation for binomials was square root of npq, right? And then, but the thing is, we're doing it per, it's kind of per item. This is for n items, a variation for n items. For one item, you take the average, you divide by n. So then this ends up being square root of n times square root of pq divided by square root of n times square root of n. So then these guys would cancel out and you're left with kind of that part there, which is the same part. That's where it comes from. It derives from that same standard deviation. Okay. Good. Then the confidence interval. So that's the first step. The second step is finding the actual confidence interval. So margin of error is just the first part. Second part is confidence interval itself. You take p hat and you subtract e, and you take p hat and you add e. And we're saying that our true proportion p naught is between those two. You can also write it in interval notation. If you wanted to. Right, which is not the top one. You have to do the addition subtraction, but this part here. P hat minus e, comma p hat plus e in parentheses. That's interval notation. So either one of those is perfectly acceptable. This is kind of the more common one. So this will be on your notes as just a reminder how to find it, but then you need to write it in this format. Problem 1B on the quiz. Find the 99% confidence interval of the true proportion. Does anybody need another 30 seconds to finish this? Everybody has it? Yeah. Okay. So here, my n is 80. My p hat is 0.25. So that means that my q hat is 0.75. And then my critical value, let's see, 99% confidence interval is 2.575. Yeah. Great. So then my error is 2.575 times square root of 0.25 times 0.75 divided by n, which is 80. And you folks got 0.125. That's not the end, that's just the first part. The second part is finding the actual interval. So the interval is my p hat minus e to my p hat plus e. That's going to be 0.25 minus 0.125 and 0.25. And you put 0.250 if you want to have the same decimal places, if that makes you feel, if you kind of feel better about that. Plus 0.125, so then you end up with 0.125 to 0.375. And that's your final 375. Okay. Good deal. So here's my final answer. Everybody all right with how we found this? Yeah. Great. So the last question was, is a portion of 28% considered large? No. It's within the confidence interval, right? Okay. Great. All right, so then let's take a look at the next thing we talked about. Alternative ways to find p hat. So either I will give you the percentage, Drew, or I will give you a number, and then the number of yeses. So So then you have to find your p hat by taking the number of yeses divided by the total, by n. How do you know whether you're given a percentage or you're given the x, the number of yeses? The percent will always have what? The percent symbol, right. It'll have a percent symbol behind it. If it doesn't have a percent symbol behind it, then it's the number of people who said yes. If it's the number of people who said yes, then that would be x people out of n people. Out of means divide. So there's your fraction. Then you have to find the p hat yourself. Remember that the n is always got to be larger, right? You can't have, it's 3 out of 4 dentists said you recommend Crest, not 4 out of 3 dentists. You can't have more than 100% of people recommending Crest. So your n is always a bigger number on the bottom. And then remember your q hat is just 1 minus the p hat. Okay. All right, and then you can find if you have a confidence interval, you can find your point estimate because how did I find my confidence interval? I started with my p hat, subtracted my error to get my lower limit, added my error to get the upper limit. So if I take these two numbers, smack dab in the middle is my p hat, right? So I just take them, average them, add them up, divide by 2 to get my p hat. My margin of error, you kind of think of that as well. Right, here's my p hat. I add my error to get to my upper limit. I subtract my error to get to my lower limit. So there's 2 e's from the upper limit to the lower limit is a distance of 2e. So I can find that distance, the upper limit minus the lower limit, and divide by 2 to get just 1e. Because the distance from here to here is 2e. So that's another way of finding it. Those are not in your notes, I don't think, so if you want them, you should write them down and take a picture, write it down if you want them. Moving on in 5, 4, 3, 2, 1. All right, so problem number 2 on your quiz. Find p hat and e. Does anybody need 30 seconds to find these? You all have them? Okay, so my p hat is going to be the average of them. 0.45454 plus 0.566 divided by 2. And I'll get 0.51. Seems right. Great. And then my e is going to be the difference of them divided by 2. So 0.566 minus 0.454 over 2. And that's 0.1112 divided by 2. 0.056. So that's my error. Yeah?
Would the P Wacom is like 5.6% and like...
Yes. So yes. Or you can also say 51%. You want to say or 5.6%. I don't care. Either one's fine. Oh, good. Yeah, thanks for asking. Okay, and then the last thing we kind of covered last class was determining sample size. So this is when you want your data to be within, you want your confidence interval to be within a certain amount of error. Like I want my error to be no more than 2%. Or I want my error to be no more than 1%. So here's the problem. My error depends upon my critical value. I have no control over the critical value. That's fixed by science, right? It's in your table. It's out there in the world. It's not something you can change in any way, shape, or form. E also depends upon p hat and q hat. I can't change that either. I can't say, hey, I need my p hat to be higher. Say yes. Say yes. You can't change, you can't manipulate your data and make people say yes so that you make your p hat larger or smaller. You can't, that's not ethical at all, right? It wouldn't accomplish what you're trying to find. But you do have control over your n. You can ask more people. And you can see as n gets bigger, you're dividing by a larger number, your error is going to get smaller. So that's how we control, you can control our error. So if we want a certain error to be within a certain amount, we just ask more people. So we can resolve by algebra. We're going to square both sides, multiply both sides by n, divide both sides by e squared, and we'll get this. On your notes, I asked you to all write this instead. If you didn't, do it now. This version instead will make your life easier. the exact same thing. It's just we're squaring them together. We're dividing first, then squaring. Instead of squaring them individually and then dividing. So your life will be a lot easier if you take the critical value, divide by e first, and then square them, instead of squaring them individually and then divide first and then square. And then multiply by p hat, q hat. The reason for that is once you square e, you'll take kind of a small number, you'll make it even smaller, so you might get that e negative 4 or e negative whatever, which is kind of a pain to deal with. So rather than coping with that, if we divide it right away, we'll have a large number, and then we'll square it, we'll have another large number, so it'll be kind of numbers that are easy to work with in a lot of ways. So that's why I recommend using this one instead. You can use either though, they are identical. This one might be a little bit easier. Okay, so remember, we're determining how many people we're going to ask before we even take a sample. So we don't know what our p hat and q hat are. So we can either use a previous estimate of p hat from a previous survey, or if we don't have that, then we just use 50-50 for p and q. If there's no estimate we can use from the past. So 0.5 for p and q, 50-50, that's how we do it. And the last thing to talk about is, remember, we have to round. Why? You can't sample a portion of a person. You can't sample 0.16 of a person. So we have to round. Why does it have to be up? Because this is the minimum. You need at least this much. 237 is not enough. You need at least 237.16, so you need at least 238. So think like if you're going to the store to buy stuff, you can't. If it's $237.16, you can't give them $237. It has to be $238 you give them. Folks want to see an example? Yes, no? No? Everyone's good with it without it?
Yeah.
Okay, great. So then we will hop straight into our quiz. For the folks at home, I'm going to go ahead and show them the example anyways, in case they want it. All right, so here's your quiz. Let's see what we got. We've got 95% confident. That means that my critical value is going to be what? 1.96. Great. Remember, you find within, you find your error. The guy says, I will guess your age within 3 years. He gets 3 years this way and 3 years that way, plus or minus 3 years. That's his error he's allowed. So within is the part you're plussing and minusing, that's your error. So I find the word within 4%, that's my error. So my E is 0.04, and I strongly recommend you really need to convert these to decimals to make this all work, or else you're going to have a giant mess. So there's two parts here. The first part is find the sample necessary. If in a prior sample, show that 40% traveled last year. That's A. Part B is if no estimate is found, how large should the sample be? That's part B. So there's two parts to this. Does anybody need just another minute to do A and B? Has everybody done it? Looks like I'll give you folks 60 seconds to do parts A and B. Now they sort of have sorted out. Just remember part A, in a previous study, 200 people showed 40% traveling overseas. That, did I give you a p hat? Did I give you a percentage? There's no percent there. You have to find your p hat from those numbers. 40 said yes out of 200. That's your p hat. Let me see that. 40 out of 200. That's your p hat. P hat. 40 out of 200. All right. 60. We'll say maybe 2 minutes. All right, everybody, listen up. Nathan's going to explain what he did. So Nathan, go ahead.
So I found the P hat and the Q hat 0.2 and 0.8. And then I did 1.96 over 0.04 squared times 0.2 times 0.8, which got 384.16, which is 385.
Yep, you have to round up to the next whole number. Perfect. Thank you. And then for P, we're using, it's the same thing, only we're using P hat is 0.5 and Q hat is 0.5. So then we'll have N is 1.96 over 0.04 squared times 0.5 times 0.5. And people got what for that one?
600.25.
600.25. So how many people do you need? 601. Great. Okay. Good. We finished that one already, so we're good with that. In case you were at home and you didn't do that part, then all right, so now we're going to jump into estimated population mean. Right. So we're going to put up for your quiz, break out your notes for chapter 7. We're working on estimated population mean. So first of all, you should all realize that same as for the first part of chapter 7, the best point estimate is my X bar, whatever I get from my sample. In other words, I take a sample. I want to know how tall all Americans are. So I take a sample of a bunch of Americans, and they have an average height of 5 foot 7.4 inches. My best guess of the heights, my sample will have an average of 5 foot 7.4 inches. What's my best guess of the heights of everybody in the country? 5 foot 7.4 inches. What have I got from my sample? So my best point estimate is my X bar, my sample mean. We're also going to learn how to find a confidence interval and sample size. So first off, I'm just going to mention some things that you folks already know, like mu or mu naught. Same thing. That's your population mean. X bar, you all know that's your sample mean. Sigma, you folks know that's your population standard deviation, right? The circle with the little tail. N, obviously, is our sample size as always. E is our margin of error as always. And then that Z alpha over 2, that's our critical value. So I will usually write that as CV. It's the same thing as our Z alpha over 2. It's the Z score that has alpha over 2 in the area. Your homework will call it Z alpha over 2. Whenever you see Z alpha over 2 in your homework, just remember that's the same thing as critical value. Right? Don't complicate things. So try to find your Z score multiplied by A divided by 2. That's not what this means. It means the Z score with alpha over 2 in the tail. Remember, we just did a couple of those, right? We did inverse norm of 0.005, and we found that that's the critical value. Didn't we do that, or did we not do that?
Yeah, we did.
Yeah. Remember, so we found all those numbers in the table. That's how you find those critical values, by inverse norm. So that's what that is, those Z scores that go along with inverse norm with that area in the table. So I'm just going to call them critical values because all my students were a lot less confused, and they did better when I called it that instead of calling it Z alpha over 2. But in your homework, the whole rest of the world calls it Z alpha over 2. So just remember, if you see that, they mean critical value. All right, so for this one, again, confidence intervals are always your statistic, your X bar or your P hat, plus or minus your critical value times your standard deviation. So in this case, it's going to be X bar plus or minus our critical value times the standard deviation, which is going to be, this is going to be S over square root of N, and we're going to talk about why that is in just a minute. Why is that? It comes from here. You folks remember that? I've talked about this a couple times. Steph Curry in 2016, right? So here's his distribution of single games. If I take a sample of 25 games and find their average, their mean of the mean, central limit theorem, which is what we're doing with the stuff all in chapter 7. We're taking a sample, we're finding the mean of that sample. So we're talking about means and means, central limit theorem. Then the standard deviation is going to be smaller. It's going to have this narrower distribution. Why? Because for every 50-point game you're going to grab, you're going to have some smaller game you're going to grab. They're going to kind of cancel each other out a little bit. So my standard deviation is not going to be 10. It's not going to be my regular sigma. It's going to be, everybody remember what it is? Sigma x bar, which is equal to what? The old sigma divided by the square root of n. Right, so remember we're talking about sample means, which is what we're dealing with in chapter 7, 8, 9. Taking a sample, we're finding the mean of that sample. So now instead of using standard deviation, we're going to use sigma x bar, sigma over square root of n. Because we're talking about mean of means, central limit theorem. So our error is going to be our critical value times our standard deviation, which is sigma over square root of n. Right? That's our first step. Our second step will be x bar minus that error, comma x bar plus that error in parentheses. That's our interval notation. So step 1, find your margin of error. Step 2, find your confidence interval. Good?
Yeah.
So this looks almost exactly like what we did for 7177, 7174, right? It should be totally familiar for folks. Right? Everybody on board?
Yeah.
Okay, good deal. We're going to skip problem number 5, so just write skip below that. We're going to, who is a good reader? I need a good reader. Okay, great, Avery, go.
People have died in a boat and aircraft accident because of an obsolete estimate of the mean weight of passengers. In recent decades, the mean weight of men has increased considerably, so we need to update our estimate of that mean so that boats, aircraft, elevators, and other such devices do not become dangerously overloaded. Using the weights of men from a random sample, we obtain these sample statistics from the simple random sample n equals 40 and x bar equals 172.55 pounds. Research from several other sources suggests that the population of weights of men is a standard deviation given by sigma equals 26 pounds.
Perfect, thank you so much. Okay, good. So here are the pieces I need. I need to know my n, that's 40. My x bar, 172.55 pounds. And my standard deviation, sigma, 26 pounds. So you need those things, circle those. The first question is, what's the best point estimate of the mean weight on the population of all men? So what's my best guess of the average weight of all men? What I got from my sample, 172.55. Perfect. Thanks, Francois. Good. So it's my x bar, 172.55 pounds. Does that make sense for folks? Whatever you got from your sample, that's what you expect the whole population to be. Now we need to construct a 95% confidence interval for the mean weight of all men. So a 95% confidence interval, that means my critical value is what? 1.96. Yep, critical value is 1.96. Perfect. So here we go. I need to find first, my first step is going to find my margin of error. So it's going to be my critical value times sigma over square root of n. So you are all writing this in with me, right? In the middle of the example. You're all writing this down in there. So it's going to be my critical value 1.96 times sigma, which is 26, over square root of n, which is 40. Great. And that is magically, we'll find it. It is right here. 8.057.
Wasn't it 366?
Right. So I'm going to make this 8.06. And then we're going to find our confidence interval. So I'm going to take my x bar, 172.55. Is that right? Yep.
Yeah.
Minus 8.06. and 172.55 plus 8.06. And I'll end up getting magically 164.49, 164.49, comma, 180.61. Done. Your data, your confidence interval should have the same number of decimal places as your data is in. So my data had, so let's see, my pounds had 2 decimal places. Everyone with me? Is there everyone paying attention?
Yes.
So my mean had 2 decimal places, 172.55. My standard deviation had 1 decimal place, 26.0. Take the one that had more decimal places. So 172.55, that's what I'm going to use, 2 decimal places. So your confidence interval should have 2 decimal places. Does that make sense for folks? So between the standard deviation and the mean, whichever one has more decimal places, use that one. All right. Good. Based upon this confidence interval, is it possible that the mean weight could be 166 pounds?
Yes.
Yeah, it's possible. It's in the range. However, since my mean is higher than that, when you're talking about safety, you don't want to go at the bottom of your confidence interval. You really want to go more towards the top, because elevators start crashing to the ground, people get upset, right? That's kind of no good. So you kind of want to pick something on the higher end. Okay, good. Great, so do not solve this. Just find these. Yeah, do you folks want to take a quick break first? Quick break?
Yeah.
Okay, let's take a quick break. We'll take a break until 16 after. Come get a chocolate. Oh, one more thing is if you're going to